Okay, let's start back up then, if everybody's set. Okay, so I'm going to talk a little bit about logging administration configuration of TVPAC server, MSTV server, whatever you want to call it. There are a lot of components to this, so I'm going to have to fly through them a little bit. Ones I'm going to focus on mostly are software installation, how do we get it on the machine, service configuration, how do we set it up so the machines each do what it is they're supposed to be doing, network management, which is how do we know that the machines are still working on a day-to-day basis in logging, which we use to analyze historically what's been going on in the service. The goals that underlie all of these areas of service administration, we're trying to build a large-scale commercial service, and so that has a number of ramifications. It's got to run lights out. We expect it to run in a data center with a bunch of machines in racks. They won't have monitors and keyboards attached. They won't have people sitting in front of them. So, also, it's going to run on a large number of hosts. Historically, both the Web TV service and the Atlas service are designed to run on redundant but not necessarily high-end hardware, and that's to keep the capital costs down for operators. The dial-up service that we operate, we've traditionally run on desktop class machines, desktop workstations, and we expect that operators will probably run this on server class Intel hardware. So that means not the really high-end dual power supply, no single point of failure kind of servers. And we expect that it'll take hundreds or thousands of machines to handle a service of the scale that we're trying to enable. As a result of the number of hosts involved, they have to be centrally administered. If you have people go around from machine to machine to do administrative tasks, it's a nightmare. You've got to hire a bunch of people to go and do things to 300 machines. And people that you can hire to do that may make mistakes along the way. And so you really have to have centralized administration. And for that, most of our administrative tools are going to be written in the context of the Microsoft Management Console, which is a nice, fancy-sounding acronym, but really doesn't mean a whole lot. I mean, give us a frame in which to implement the tools. But they will fit into that. So that in terms of how you navigate to the administrative tools, it'll be the Win2K standard way. And finally, the service needs to be centrally monitored so that you can have operators sitting in front of a commercial network monitoring console, and they can have a lot of data available to them as to whether the service is having any problems, whether the users are seeing any of those problems, and what the general health of the service is, how busy are the machines, and so forth. Software installation I'm only going to touch on briefly. In this area, if you look at the VDR release right now, we provide installer, which is sort of a Windows 2000, Microsoft standard installer. Double-click on it, installs the software, and that's a useful installation model for demos and trial setups and installing it on your desktop to use it for development. But it's not a particularly useful installation model for a data center, where once again you'd have to go to 300 machines, hook up a monitor and keyboard in order to do that double-clicking. So the 1.0 installer will have both the graphic interface for installation, and it'll have an unattended mode of installation, so that you can install it on machines that don't even have a monitor keyboard attached. On the other hand, there are some problems that we're not solving in 1.0. We'll provide this installer that you can run unattended. It's command line, so there are various ways that you can get it to run remotely. We are not implementing a bunch of tools for the installation of software on lots of machines simultaneously. We provide an installer that you can automate, you can script it, but we're not providing that automation or that scripting. There are some technologies designed for doing this. The Microsoft installer that came out with Windows 2000 has some features for doing this, and Microsoft SMS has some features for doing this. So from a deployment standpoint, there are solutions to this problem. We're not, in the core development group, we're not doing any work with SMS. It's quite possible that you'll be able to use SMS to deploy this software, but we don't have the resources to try that out for 1.0. Hopefully post 1.0, we're going to try and at least provide sample integrations with more of the deployment tools as part of the core technology. Terminologically as well, I think that the configuration model is a little different from a lot of Windows products. We tend to talk about installation and configuration as two separate processes. And at install time, all you're really doing is putting the software on the machine. A lot of installers will ask you a lot of questions about what SQL server do you want to use, and what mode do you want to install it in, and what server do you want to talk to. None of that is included in our installation process. When you run the installer, even the graphic code, all it really does is place the software on the machine. You have to tell it where to put this, but you don't tell it, for example, which applications will this machine be running. The front-end machines that run things like mail and PCs and favorites and search, they all have all the applications installed. You don't install different software on different machines. Operationally, that's an advantage because it means that if you need to repurpose a machine, the bits are already there. And it makes your operational configuration much simpler. And quite honestly, the amount of disk space occupied by this stuff is irrelevant compared to the size of modern disks. So the strategy is to install all the bits. And then once the bits are installed, there's a configuration process that's done centrally. And that's what I'm going to talk about next, is how you configure the service. So you have a bunch of machines. You've installed the product on each of them. None of the machines knows which applications it's supposed to be running. It's got the bits for all of them. So the next step is to configure your service. Now, once again, it has to be centrally done. You can't go out to each machine and configure it. So there's a configuration system where there's a central configuration file that describes for all of the machines in the service what it is they're supposed to be doing. It's designed to be a relatively efficient format to edit. So you can describe, for example, a proxy machine should run the proxy server and a system monitoring server, and the proxy server should have the following TCP settings. And you can describe this all kind of in a higher level way, and then say, oh, and the following 17 machines are all proxy servers, and they'll all get that set of configuration information. And for editing the configuration file, there's an MMC snap-in that was not part of DPR, but will be part of the 1.0 release. So that's the configuration edit. And that's probably the most important. Maybe I'm biased because it happens to be within my group, but that's probably the configuration of the MMC snap-ins we provide. That's probably the one that operators will spend the most time using, because that controls the configuration of pretty much all the applications we write. In addition to that, there are some other MMC snap-ins that you use to do some of the database configuration, some of the whitelist configuration, and so forth. And then when you edit the configuration, the centralized administrative workstation, it saves the changes locally, and then it pushes the changes out to each of the machines, which then pick up the changes and start with the new configuration. The next area that I want to talk about was network management. This is a very important area. If you're running a large commercial service, I guess we talked about this a little earlier, machines fail left and right. It wouldn't be unusual to have a machine fail every day. So in terms of the general architecture of the service, the first goal is that if a machine fails, the users don't notice. Most of the machines are redundant. In fact, I want to say that virtually everything in the service can be redundant. So when a machine fails, the users see a prolonged outage, but on the other hand, the operators need to know about it, because if you just let machines fail and you don't know about it, then eventually they'll all the redundant machines will have failed after enough time. So although users don't notice the failures, the operators need to about them right away so they can put them on their list of machines that need to be fixed within a day or two. So for monitoring, there's a bunch of monitoring data that's available, much of which isn't specific to TV server. Windows 2000 gives you a lot of instrumentation. It'll let you hook up and find out things like how busy is the machine, how busy are its disks, how much memory does it have available. And that information is all extremely useful in terms of monitoring the health of a server. Similarly, the Internet Information Server provides us with a bunch of information. How many pages is it serving a second? How much data is it serving up? Stuff like that. So between those two, you get a not bad picture of the health of the service. Then there's some other things that we're going to try and provide over and above that. Two in particular. One is that we have a monitoring application. And the monitoring application is a little bit different from all sort of performance-oriented data you get from Windows 2000 and Internet Information Server. The monitoring application actually goes out and pretends it's a set-top box and makes requests to the application. So it'll go to the home page, and it'll ask for a copy of the home page. And then it'll parse the home page, find out all the images that are on the page, and it'll go and fetch all the images. And so it does the operations required to actually get a home page. And if any of those operations fail, then it's going to raise an alarm to the monitoring console. And the reason this is there is so that you catch that's really a good end-to-end test of the service. There are a variety of failures that could happen that maybe you're still serving pages and you're serving lots of bytes and you're still using up the amount of CPU, but the bytes you're serving are all wrong. And so this application is to catch the sorts of errors that other monitoring systems won't catch. So it's noting that the tests that it runs are application specific. So for each of the applications that we provide a corresponding test that knows how to talk to that application, what responses to expect back, how to tell if it's actually gotten a bad response. I guess the other thing to note is that even from a protocol standpoint, it acts like a real client. It talks to the services across the network, not from the local machine. So it'll catch, for example, connectivity failures, and it speaks the same protocol to clients. So it speaks WTVP. Then this data is fed up to the monitoring console via like SNMP, a standard management protocol. It's worth noting that we don't sell a managed console. We don't provide a user interface for monitoring the health of the service. There are third parties that sell these things. HP is the one that we work the most closely with. CA and Tivoli are other vendors. From a 1.0 standpoint, it looks like the 4 showcase customers are likely to all be using OpenView. They either have a preference for OpenView or they're asking us what we recommend. So if we can steer them all to OpenView, we're in a pretty good position, because then we can go out and we've been talking with Open over the last few weeks, talking with HP, and we're going to work with them to make sure that we integrate well with OpenView. And so it's a good direction to steer customers. That said, all the protocols that we use for gathering management information are standard protocols. We use the Simple Network Management Protocol, and we use Web-Based Enterprise Management, which are both widely supported by consoles. Basically, SMP is the traditional protocol that's been used for many years. WebM is a new protocol that's more functional, and Microsoft is kind of back. And so we're going to be doing some combination of the two. The last area I want to talk about is logging. I think Joy probably covered some of this. I noticed a lot of correspondence between her slides and mine in this area. All the servers and TV servers keep a very detailed record of what they do when they're running. So every time a user fetches an image or an HTML page, every time a client hooks up to CCS and downloads a release of the software or an ad, a log is recorded that indicates what happened. So it indicates what the client did, what the client requested from the service, and when appropriate, it indicates some other things, like how did the user get there. Whenever the user goes to a web page, we log not only where they went, but where they came from. And if you string those together, you can actually understand a lot about user behavior, because you can understand the path they take through the service. Like, do users get to mail from the home page, or do they get to mail from mail to URLs? You can understand a lot about what features those people are using. We get the client can log information about how long it spent on a given web page. So not only do you know where they went, you know how long they spent there, which can be important if you want to, once again, understanding use patterns, understanding how long certain ads are on screen. You also have things that are useful when you look back at the reliability of the service, like, did the operation succeed? You can go back and historically understand the number of failures.
In context, can you define operation?
Yeah, typically an operation is an HTTP transaction. So it's an HTTP GET or POST. There are some other things that count as operations. For example, a session with the configuration server is an operation. And there are some kind of artificial operations that we create just as ways to log data. So the philosophy is actually to get as much data into this log as we can. So we'll periodically log information about the health of the server to this log, and we'll write that in as a transaction to the log if it's not really an operation. Pretty much anything the server does, we try to find ways to log stuff with its health when the data volume is appropriate. So there are a lot of things that count as operations. So the other thing log is some performance data, like how long did the operation take and how much data did it send down. So using these logs, historically you can do a lot of different kinds of analysis. You can understand what the traffic patterns look like, what the error rates look like, what the response times look like, what the load look like. So for capacity planning, this data turns out to be quite important. The client also does a lot of logging. We've been working with the client to make sure that the client logging and the server logging work well together. So some of the client logs that are important is the configuration log, which is often called the phone log for historical reasons, which records data like when did the client connect to the service, when did it power on, when did it power back off, and also a bunch of configuration information, like were there any peripherals connected. I actually, in this, I don't know exactly what the set of things that set-top boxes will record, but if they have printer ports and they can tell whether a printer is attached, they'll log that. If they have Ethernet ports, they'll log whether those were in use. We log whether a remote has been used, whether a remote keyboard has been used, so you can understand a lot about what peripherals customers have in their homes. There's also the TV log, which I think Joy talked about, which is very important. The log tells you everything that happens with the printer. So when does the box change channels? And then we also can know what were they doing on the remote. So, reconstructing the Nielsen ratings is an interesting challenge because we have the same problem Nielsen does. You don't actually know whether the TV is powered on or a person sitting in front of it. All you know what channel it's to. But you do know that if there's someone clicking the remote, either sitting there watching TV or their cat's walking on the remote. And so ignoring the cat problem, knowing when the last time they touched the remote is an important thing in terms of guessing what their viewing habits are. So the client keeps track of all that. What was the tuner doing and what was the remote doing? And based on that, you load that stuff into the warehouse, apply some heuristics, and you can do a decent job of figuring out people's viewing habits. In particular, there are some really interesting problems that we could solve. You could ask a question during the Super Bowl when some particular obnoxious ad comes, how many people turn away? Right? We have all the data for that. It's one that a cable company brought up. It's a sort of interesting thing to study. What do users do when ads come on? Do they tune or turn away? Which is something that not even Neil can really tell, because they track your use on a more like program-by-program basis, not like what do you do during the ads? Do you flip away or do you stay? The client logs its crashes. Anytime the client crashes, it tries to save some stack information on the way down. Yeah.
Yeah, and where is the state on the last?
Well, so far it's logged to the client disk. I'm going to talk in a minute about how to get the data. Well, the client non-volatile storage, so either the flash or the disk, or I guess all the clients in question have either flash or disk. So
it's stored in the client storage area, and then we put it somewhere.
Yep, that's right. Yeah, we'll do it on the next slide. And then there are also application logs. Applications can log about their own failures. And this is mostly for use for applications that are developed to go on the client. Anything that an OEM, a MSTV client wants to write can log data. In terms of getting the data up to the service, it's sent up client configuration server that Dave was talking about. And it's worth noting the general mechanism. So if a customer does write a custom application on the client, the same mechanism can be used to gather the logs. They don't have to write new log collection code. So the data comes up to the service via the CCS, and then we've been negotiating with the client team. What's going to happen is the log comes up to the service, and then there will be a converter that takes the log that's in the client format and converts it to match the server format and logs it to the server log. And so in that way, we can support logs in a bunch of different formats. We don't have to write a bunch of server code that knows about the formats. It's just a pluggable architecture where you install a DLL for each kind of log. So if a MSV licensee develops a new log format, then they just need to supply the service with a converter DLL. The service will be happy to convert their logs and log them to the MSTV log. So, go ahead.
And it doesn't stay in TV server log. This data ends up in some database somewhere.
That's right. Yeah, and that's even the next slide. So the data starts out on the client disk. So the data starts out on the server disk, the logs that are generated by the servers. So all those logs get put into a big log that's on the disk of the individual server machines. So in a server farm, we've got 150 front-end machines. All 150 have a big log of all the stuff they've been doing recently. Those logs are very useful, scattered around in 50 machines. You need them to be centralized. So there's a log aggregator that goes out and talks to all the front-end machines and gathers their logs in pretty close to real time. It's talking to them all the time. During a load spike, it might get a little bit lagged, but it generally has to keep them up to date. The reason they're logged to disk on the client first, actually, is just from a fault standpoint. Connection fails if the aggregator has a problem for a few minutes. The clients, the front-end machines keep logging to disk, and then when the aggregator comes back up, it'll connect to them and it'll say, hey, give me your logs as of the following time. It'll pick up where it left off and get the logs. But in practice, we try to get them up to the aggregator pretty quickly. So there actually are some things you can do with the aggregator that you can't do with the data warehouse that we do in the telco service, and I expect that some of it will be interesting in the cable world. You can see in pretty real time what the service is doing. You can, if you're trying to diagnose a problem, you can watch the activities of a particular box. You can see it try to connect and the error it's getting back. If you want to understand the health of your cable network, you can look for errors that clients are having. For example, the client team is trying to figure out the right set of network diagnostics to send up. So lost packets or problems with the DOCSIS cable network. And so if they can send that data back up, then in real time you can, out of this stream of logs, you can find out what sorts of failures the client's seeing, and you can understand if there's a systemic problem in your cable network. So we're providing the mechanism for doing that. We don't actually in 1.0 have tools for diagnosing cable network failures and for correlating things. There's a general mechanism for telling the service that you want to see all the logs in a particular area. You want to see all the client error logs. And then on top of that, you can build tools that will correlate them, which actually the folks who run the telco service have done in a couple instances. Like they study the health of the dial-in ports, for example, in this way. They grab the logs in real time, they stuff them into a little SQL database, and then they can run reports in real time and see which dial-in areas have been failing, which ones they've been succeeding. It's actually pretty similar to the problem of understanding a cable network failure. So now we've gotten the log in the client from the servers, they've gotten onto the aggregator. The next step is to get into the warehouse. That's not a real-time process at present. The warehouse gets loaded in batch mode. The US and I suspect the one cable service both do that nightly. So every night we run a batch job, it gets through the day's logs, it converts them into a format that the data warehouse understands, and they get loaded into the warehouse. So finally, in the warehouse, we have much more sophisticated analysis capabilities. Not every bit of data goes in there, so there are still some things that you need to go back to the logs for. Joyce worked hard to make sure that all stuff that we expect people for business analysis makes it into the data warehouse. And that is all that I had on my list. Any got any questions about any of those rather broad areas?
Great.
It's been a long day.
Thanks.
No problem.
That's it.
Cool.